What if everything you thought you knew about reality was just a fraction of the truth? What if somewhere beyond the edges of our universe, another reality exists, hidden from view until it isn't? Picture this, a moment where the boundaries between these worlds dissolve and two universes collide. What would happen? Would time and space unravel? Would new laws of physics emerge, or would chaos reign supreme? These aren't just questions for science fiction, they're bold theories that scientists and thinkers are exploring right now. From the mind-bending possibilities of parallel realities to the cosmic shockwaves of such an event, the intersection of two universes challenges everything we think we know about existence. And here's why it matters. It forces us to confront the limits of our understanding and reimagine the very fabric of reality. So, let's take a journey into the unknown, where science meets imagination, and explore what could happen if two universes intersected. By the end of this, you might just see the cosmos and your place in it in a whole new light. To grasp the idea of multiverses, let's start with a simple yet mind-bending question. What if our universe isn't alone? Imagine a vast cosmic tapestry where each thread represents an entirely separate universe, each with its own rules, its own physics, and its own version of reality. This is the essence of the multiverse theory, a concept that has moved from the fringes of speculative thought into the heart of modern theoretical physics. Scientists propose that beyond the observable edges of our universe, there could be countless others, each existing in its own bubble, completely unaware of the others. Some might be strikingly similar to ours with only minor differences, while others could be unrecognizable, governed by laws of physics so alien that even time and space might behave in ways we can't comprehend. But here's where it gets truly fascinating. What if these universes, usually isolated from one another, were to somehow touch or even overlap? What if the barriers between them, which we assume are impenetrable, suddenly gave way? This isn't just a wild thought experiment, it's a question that some of the most brilliant minds in science are actively exploring. The multiverse theory opens the door to possibilities that challenge our understanding of existence itself. It suggests that reality might be far more complex, layered, and interconnected than we've ever imagined. And if that's true, then the idea of two universes intersecting isn't just science fiction. It's a scenario that could redefine the very nature of reality. So, what would it take for such a collision to occur? What forces or events could bring two universes together? And what would that mean for everything we know? What would it take for two universes to collide? To even begin answering this, we need to dive into the realm of theoretical physics, a field where the rules of our everyday reality no longer apply. One of the most intriguing ideas comes from string theory, a framework that suggests our universe might not be the only one out there. In fact, it proposes that our universe could be just one of many branes, short for membranes, floating in a higher dimensional space. Think of these branes as soap bubbles drifting in a vast cosmic bath. Most of the time, they float independently, never touching. But what if two bubbles were to drift close enough to merge? That's the kind of scenario physicists imagine when they talk about universe collisions. But how does this work in practice? In the context of string theory, branes can exist in dimensions beyond the three spatial ones we experience: length, width, and height plus time. These higher dimensions are impossible for us to perceive directly, but mathematically, they provide a playground for theories like universes colliding. If two branes were to collide in this higher dimensional space, the impact could send ripples through both universes, potentially altering their very fabric. This idea isn't just speculative, it's rooted in calculations that suggest such events could explain phenomena like the Big Bang itself. Some scientists even propose that our universe might have been born from a collision between two branes. Quantum entanglement adds another layer to this cosmic puzzle. While it's usually discussed in the context of particles being mysteriously linked across vast distances, what if entire universes could become entangled? If two universes shared some form of quantum connection, their collision might not just be a chaotic smash, it could be a carefully orchestrated dance, governed by laws we're only beginning to understand. The implications are staggering. What if the fundamental constants of physics, like gravity or the speed of light, shifted as a result of such an event? Could life as we know it even survive? To make this more relatable, let's return to the soap bubble analogy. Imagine two bubbles floating side by side. They're separate, yet their surfaces are so close that they're almost touching. Now picture one bubble gently nudging the other. The moment they touch, their surfaces merge, creating a single, larger bubble. In the same way, if two universes collided, their boundaries could dissolve, blending their distinct laws of physics into something entirely new. This merging might not be violent or destructive. It could be a seamless fusion, reshaping reality in ways we can't yet predict. So, while the idea of universe collisions might sound like science fiction, it's grounded in cutting-edge theories that push the boundaries of our understanding. The real question isn't just whether it's possible, it's what happens next. What would such an event look like from our perspective? Would we even notice, or would the changes be so profound that reality itself becomes unrecognizable? As we explore these questions, we're not just pondering the fate of our universe, we're redefining what it means to exist in the first place. What if the birth of our universe wasn't a singular, isolated event, but the result of something far more dramatic, a collision between two universes? This is the core idea behind the Ecprotic universe model, a theory that reimagines the Big Bang as the aftermath of a cosmic crash. Instead of a single point of infinite density exploding into existence, this model suggests that our universe was born when two higher dimensional branes, those soap bubble-like structures we discussed earlier, smashed into each other. The energy released from this collision could have sparked the rapid expansion we call the Big Bang, setting the stage for everything we see today. But why does this matter? If the Ecprotic model is correct, it changes how we think about the origins of our universe. It implies that the Big Bang wasn't the beginning of everything. It was just one chapter in a much larger cosmic story. This theory also raises a tantalizing possibility. If universes can be created through collisions, could the same process happen again? Imagine two universes drifting through higher dimensional space, their paths slowly converging. When they meet, the impact could unleash enough energy to birth an entirely new universe, complete with its own laws of physics and unique structure. This isn't just a fascinating what if, it's a theory that has real implications for our understanding of reality. If new universes can form through collisions, it means the multiverse might be far more dynamic and interconnected than we've ever imagined. It also suggests that the birth of our universe wasn't a one-time event but part of an ongoing cosmic cycle, where universes are constantly being created, destroyed, and reborn through these monumental collisions. Now, let's take this idea one step further. If universes can collide to create new ones, what would happen if two existing universes collided today? Would it be a catastrophic event, tearing apart the fabric of both realities? Or could it be more like a merger where the two universes blend seamlessly, creating a new hybrid reality? Some theories suggest that the collision might not be immediately noticeable to us, as the changes could occur in dimensions we can't perceive. Others propose that the effects would be profound, altering the fundamental constants of nature and reshaping the very rules that govern existence. To put it in perspective, think of two rivers merging into one. The water from both sources flows together, creating a single, larger river with a unique current. In the same way, if two universes collided, their laws of physics might combine, producing a new set of rules that neither universe had before. This could lead to entirely new forms of matter, energy, or even life, as the merged universe adapts to its new reality. The idea of universe collisions challenges us to think beyond the limits of our own reality and consider the possibility that we're part of something much bigger, a multiverse that's constantly evolving. Whether these collisions create new universes or reshape existing ones, they remind us that the cosmos is far more mysterious and interconnected than we've ever imagined. And as we explore these theories, we're not just learning about the universe, we're redefining our place within it. What would it look like if two universes collided? Would it be a violent, chaotic explosion or a quiet merging of realities? The immediate effects of such an event are as fascinating as they are terrifying. Picture this: the moment two universes intersect, their boundaries dissolve, and the very fabric of space-time begins to warp. The energy released from such a collision could be unimaginable, perhaps even comparable to the Big Bang itself. This energy might manifest as cosmic shockwaves, rippling through both universes and altering everything in their path. Stars could be flung from their orbits, galaxies torn apart, and entire regions of space reshaped in an instant. But chaos isn't the only possibility. Some theories suggest that a universe collision could also lead to creation. Imagine the collision as a cosmic forge, where the intense energy and pressure give rise to entirely new forms of matter and energy. Strange particles never before seen might emerge, and the laws of physics could rewrite themselves in real time. It's a scenario where destruction and creation are two sides of the same coin, and the line between them blurs in ways we can hardly comprehend. One of the most profound implications of a universe collision is the potential for spacetime itself to be reshaped. In our universe, spacetime is the stage on which everything plays out, the framework that holds reality together. But if two universes collide, their distinct spacetime fabrics could merge, creating a new hybrid structure. This could lead to phenomena like time dilation, where time flows differently in different regions, or even the emergence of entirely new dimensions. The rules we've come to rely on, like causality and the speed of light, might no longer apply, replaced by a new set of cosmic laws. And what about life? If two universes collide, the effects on any existing life forms would depend on how drastically the collision alters their environment. In a catastrophic scenario, entire civilizations could be wiped out in an instant, their worlds torn apart by the sheer force of the collision. But in a more controlled merging, life might adapt, evolving to survive in a reality with entirely new physical constants. Imagine organisms that thrive in a universe where gravity is weaker or where time flows backward in certain regions. The possibilities are as limitless as they are unpredictable. This brings us to a deeper question: could a universe collision be both destructive and creative at the same time? The answer might lie in the nature of the universes themselves. If two universes with similar physical laws collide, the result might be a relatively smooth merging with minimal disruption. But if the universes are vastly different, perhaps one where matter behaves in ways we can't even imagine, the collision could be far more chaotic, leading to unpredictable outcomes. As we explore these ideas, it's important to remember that this isn't just speculative fiction. These are real theories being explored by physicists and cosmologists, pushing the boundaries of our understanding. The collision of two universes isn't just a dramatic event. It's a window into the fundamental nature of reality itself, challenging us to rethink everything we thought we knew. And as we ponder these possibilities, we're not just imagining the end of one universe, we're glimpsing the potential for something entirely new to emerge from the chaos. What would happen to life if two universes collided? This isn't just a question about stars and galaxies, it's about the fate of every living being caught in the crossfire. Imagine civilizations thriving in their own isolated realities, completely unaware that their universe is about to intersect with another. For advanced life forms, the first sign of an impending collision might not be a dramatic explosion but subtle anomalies in their environment. Strange gravitational waves, unusual energy fluctuations, or even distortions in space-time itself could serve as early warnings. But would they have enough time to prepare? Survival might depend on their ability to detect the collision before it's too late and adapt to the unimaginable changes it brings. Consider this: if a civilization had the technology to monitor higher dimensions, something we can barely conceive of, they might detect the approach of another universe long before the collision occurs. This advanced warning could give them a chance to take extraordinary measures. Picture massive planetary shields designed to protect entire worlds from the energy surges of the collision. Or perhaps interstellar arcs capable of transporting entire populations to safer regions of their universe, or even beyond. The idea of inter-universe migration might sound like science fiction, but in the face of such a cosmic event, it could become a necessary survival strategy. But what about less advanced life forms? For species that lack the technology to detect or escape the collision, the outcome could be far more dire. Entire ecosystems might be obliterated in an instant, their worlds torn apart by the sheer force of the merging universes. Yet, even in the face of such destruction, there's a glimmer of hope. Some theories suggest that a universe collision might not be uniformly destructive. Certain regions could remain relatively stable, allowing pockets of life to survive and even thrive in the aftermath. These survivors would find themselves in a radically altered reality, where the rules of physics have shifted and the very nature of existence has been rewritten. One of the most intriguing possibilities is the potential for inter-universe communication. If two universes share a quantum connection, it's possible that advanced civilizations could establish some form of contact before the collision even occurs. This could open the door to unprecedented collaboration, as civilizations pool their knowledge and resources to prepare for the event. Imagine a cosmic alliance where beings from two different realities work together to build technologies capable of withstanding the collision or even harnessing its energy for their own survival. For humanity, the question becomes even more personal. Could we ever witness such an event? The answer depends on how close we are to the collision's epicenter and whether we've developed the technology to detect it. If a universe collision were to happen on the fringes of our observable universe, we might not notice it at all, at least not until its effects began to ripple through our reality. But if it occurred closer to home, the consequences would be impossible to ignore. Entire galaxies could be reshaped, and the fundamental constants of nature could change, leaving us to grapple with a reality that no longer follows the rules we've come to rely on. In the end, the collision of two universes isn't just a cosmic event. It's a test of resilience for all life forms involved. Whether it leads to survival or extinction depends on countless factors, from the nature of the collision itself to the ingenuity of the civilizations caught in its wake. As we explore these possibilities, we're not just imagining the fate of distant worlds, we're confronting the fragility and adaptability of life itself. And in doing so, we're reminded that the universe, in all its vastness and mystery, is a place where even the most unimaginable events can reshape the course of existence. What if a universe collision happened right now? Could we even detect it? The answer isn't as straightforward as you might think. To begin with, we'd need to look for clues in the fabric of our own universe, searching for anomalies that hint at something extraordinary happening beyond the boundaries of our reality. One of the most promising signs could be gravitational waves, ripples in space-time caused by massive cosmic events. We've already detected gravitational waves from black hole mergers and neutron star collisions, but a universe collision would produce waves on an entirely different scale. Imagine gravitational waves so powerful that they distort spacetime itself, creating patterns we've never seen before. These waves could serve as the first alert that something monumental is happening. But gravitational waves might not be the only signal. Cosmic radiation could also hold clues. If two universes collided, the immense energy released might flood our universe with exotic particles or high-energy radiation, creating bursts that light up our telescopes in unexpected ways. Similarly, the cosmic microwave background, the faint afterglow of the Big Bang, might show irregularities or patterns that point to an external influence. These anomalies could be like fingerprints, evidence of another universe brushing up against our own. Detecting these signs, however, comes with enormous challenges. For one, our understanding of higher dimensions where universe collisions are theorized to occur is still in its infancy. We can't directly observe these dimensions, so we're forced to rely on indirect evidence, piecing together clues from the effects they have on our own reality. It's like trying to understand the shape of an object by only seeing its shadow. We're limited by the tools and theories we have, and the sheer scale of a universe collision makes it even harder to interpret what we might be seeing. Another hurdle is the timescale of such an event. If a collision happened billions of light years away, the signals might take eons to reach us. By the time we detect them, the event itself could be long over. Even if we did observe something unusual, how would we distinguish it from other cosmic phenomena? The universe is full of mysteries, and teasing apart a universe collision from, say, a supermassive black hole merger or a gamma-ray burst would require unprecedented precision and insight. Yet, the idea of detecting a universe collision isn't just a scientific challenge, it's a philosophical one. If we were to find evidence that another universe had collided with ours, what would that mean for our understanding of reality? It would force us to confront the possibility that we're not alone, that our universe is just one piece of a much larger puzzle. Such a discovery would redefine our place in the cosmos, challenging us to think beyond the limits of our own existence. Imagine the implications. If we could detect a universe collision, it would open the door to a new era of exploration, one where the boundaries between worlds aren't just theoretical but observable. It would be a reminder that the universe is far stranger and more interconnected than we've ever imagined. And while the challenges of detection are immense, the potential rewards unlocking the secrets of the multiverse are equally profound. As we continue to push the boundaries of science, we're not just searching for answers, we're redefining the questions themselves. What does it mean for reality if two universes could intersect? This question takes us beyond the realm of physics and into the heart of philosophy, where the boundaries of existence itself are called into question. If our universe is just one of many, and if these universes can collide or overlap, what does that say about the nature of reality? For centuries, philosophers have debated whether the world we perceive is all there is, or if there's something more, something hidden beyond our senses. The idea of intersecting universes pushes this debate to its limits, suggesting that reality might be far more layered and interconnected than we've ever imagined. At the core of this discussion is the concept of existence itself. If multiple universes exist, each with its own set of physical laws and constants, what does that mean for the idea of a single objective reality? Could it be that reality is not a fixed, unchanging truth, but a fluid, ever-shifting tapestry of possibilities? This idea challenges the very foundation of how we understand the world. It suggests that what we perceive as real might only be one version of many, each equally valid in its own context. The implications are profound. if reality is relative, then our understanding of truth, identity, and even consciousness might need to be redefined. Time and space are two other pillars of existence that come under scrutiny in this scenario. In our universe, time flows in one direction, and space is a three-dimensional stage where events unfold. But what if another universe operates under different rules? What if time loops back on itself or moves in multiple directions? What if space has more dimensions than we can perceive? The intersection of two such universes could create a hybrid reality where these concepts no longer hold. Imagine living in a world where the past, present, and future coexist, or where distances are measured not in miles but in entirely new ways. Such a reality would force us to rethink not just how we live but how we experience life itself. The blurring of lines between science and metaphysics is another fascinating aspect of this discussion. Traditionally, science deals with observable, measurable phenomena, while metaphysics explores the nature of existence beyond the physical. But when we consider intersecting universes, these two fields begin to overlap. The multiverse theory, for example, is rooted in scientific models like string theory and quantum mechanics, yet it raises questions that feel deeply metaphysical. Are these universes separate entities, or are they different facets of a single, unified whole? Does the existence of multiple realities imply a higher order or purpose, or is it simply the result of random chance? These are questions that science alone cannot answer, inviting us to explore the philosophical dimensions of our existence. One of the most intriguing philosophical questions raised by intersecting universes is the nature of free will. If multiple realities exist, each representing a different set of choices and outcomes, does that mean our decisions are predetermined? Or does it suggest that every choice we make creates a new branch of reality where all possibilities are equally real? This idea, often explored in discussions of quantum mechanics, challenges our traditional notions of cause and effect. It implies that the future is not fixed but fluid, shaped by the countless decisions made across multiple universes. For some, this is a liberating thought, a reminder that our choices matter and that we have the power to shape our own reality. For others, it's a daunting one, suggesting that every action creates infinite versions of ourselves, each living out a different path. As we grapple with these questions, we're reminded that the intersection of universes isn't just a scientific curiosity, it's a profound philosophical challenge. It forces us to confront the limits of our understanding and to consider the possibility that reality is far stranger and more complex than we've ever imagined. Whether it's redefining time and space, blurring the lines between science and metaphysics, or rethinking the nature of free will, the idea of intersecting universes invites us to explore the deepest mysteries of existence. And in doing so, it doesn't just change how we see the universe, it changes how we see ourselves. What if every decision you've ever made or will make exists somewhere else in another version of reality? This is the mind-bending idea at the heart of free will in a multiverse. If intersecting universes truly exist, then every choice, every action, could spawn infinite alternate realities, each one playing out a different outcome. Think about it. In one universe, you might have taken that job offer across the country, while in another, you stayed put. Both versions of you are equally real, living out their lives in parallel. But here's where it gets even more intriguing. What happens when two universes collide? Could their infinite timelines merge, creating a tangled web of possibilities where every decision is both made and unmade? The concept of free will takes on a whole new meaning in this context. If every possible choice exists somewhere in the multiverse, does that mean our decisions are predetermined? Or does it mean we have the ultimate freedom, a chance to explore every possible path, even if we're only aware of one? Philosophers and scientists have wrestled with this question for centuries, but the idea of intersecting universes adds a fresh layer of complexity. Imagine two universes, each with its own set of timelines, suddenly colliding. The result could be a blending of realities where alternate versions of events coexist in a single, unified timeline. This merging might not erase the choices we've made, but it could create a new reality where those choices are both true and false at the same time. This raises a fascinating question. Could intersecting universes lead to paradoxes? If two universes with conflicting timelines merge, what happens to the events that don't align? For example, what if in one universe a key historical event unfolded one way, while in the other it took a completely different turn? When these universes collide, could we end up with a reality where both outcomes are simultaneously true? It's a scenario that challenges our understanding of cause and effect, forcing us to rethink the very nature of history and time. Paradoxes like these might seem impossible, but in a multiverse where the rules of reality are constantly shifting, they could become the new normal. To make this more relatable, consider the concept of Schrödinger's cat, a thought experiment where a cat in a box is simultaneously alive and dead until observed. Now scale that up to the level of universes. If two universes collide, their combined reality might exist in a state of superposition, where multiple outcomes are true until observed or resolved. This doesn't just apply to individual choices but to entire histories. The merging of universes could create a reality where the past, present, and future are all fluid, constantly shifting as the timelines intertwine. But what does this mean for us as individuals navigating our own lives? If intersecting universes create infinite possibilities, does that mean we're powerless to shape our own destinies? Not necessarily. Some theories suggest that while alternate realities exist, our conscious awareness is tied to the timeline we inhabit. In other words, even if infinite versions of us are making different choices, the version we experience is the one we actively create. This idea offers a reassuring balance between the infinite possibilities of the multiverse and the sense of agency we feel in our own lives. It suggests that while the multiverse might contain every possible outcome, our choices still matter, because they define the reality we live in. As we ponder these questions, we're reminded that the intersection of universes isn't just a scientific or philosophical curiosity. It's a deeply personal exploration of what it means to exist. Whether it's redefining free will, grappling with paradoxes, or imagining the infinite paths our lives could take, the idea of intersecting universes challenges us to think beyond the limits of our own reality. And in doing so, it doesn't just expand our understanding of the cosmos, it invites us to reflect on the choices that shape our own lives and the infinite possibilities that lie just beyond the horizon. What happens when the unthinkable occurs when two universes, each governed by their own unique laws of physics, collide? The result isn't just a clash of matter and energy, it's a collision of realities themselves. And when realities collide, paradoxes can emerge, situations where the rules of one universe directly contradict the rules of another. Imagine a universe where time flows backward, intersecting with one where time moves forward. What happens to cause and effect in such a scenario? Does an event in one universe trigger its opposite in the other, creating a loop where actions cancel themselves out? These aren't just hypothetical puzzles. They're real risks that could arise if universes with incompatible laws were to merge. One of the most striking examples of this is the grandfather paradox, a classic thought experiment in time travel. In its simplest form, the paradox goes like this. If you travel back in time and prevent your grandfather from meeting your grandmother, you would never be born. But if you were never born, how could you have traveled back in time to interfere in the first place? Now, apply this to intersecting universes. If one universe operates under different laws of causality, where the future can influence the past, and it collides with a universe where cause and effect are strictly linear, the result could be a reality where events contradict each other endlessly. It's a cosmic tug-of-war where the very fabric of logic begins to unravel. But paradoxes aren't the only danger. Contradictions in physical laws could lead to even more dramatic consequences. Picture a universe where gravity is 10 times stronger than in ours, colliding with one where gravity is negligible. The sudden shift in gravitational forces could tear apart planets, stars, and even galaxies, creating a chaotic mess of matter and energy. Or consider a universe where the speed of light is infinite, intersecting with one where it's fixed. The fundamental constants that govern everything from atomic interactions to the expansion of space could become unstable, leading to a breakdown of reality as we know it. In such a scenario, the very foundations of existence might crumble, leaving behind a universe that no longer follows any recognizable rules. To make this more tangible, let's revisit the soap bubble analogy. If two bubbles represent universes with different physical laws, their collision isn't just a merging of surfaces, it's a clash of the forces that define them. The moment they touch, the tension between their differing properties could cause the bubbles to pop, destroying both in an instant. In the same way, a collision between universes with incompatible laws might not result in a seamless merging but in a catastrophic collapse of both realities. The energy released from such an event could be so immense that it reshapes the very structure of space-time, leaving behind a chaotic void where neither universe survives. Time plays a particularly fascinating role in these scenarios. In our universe, time is a one-way street moving from past to future, but in another universe, time might loop back on itself or flow in multiple directions. When these universes intersect, the resulting timeline could become a tangled web, where events from different realities overlap and interfere with each other. Imagine a moment where the past, present, and future of two universes collide, creating a reality where everything happens at once, or perhaps nothing happens at all. The implications are staggering. What if the collision erases entire histories or creates new ones that never existed before? These paradoxes and contradictions aren't just theoretical, they're a reminder of how fragile the fabric of reality might be. If intersecting universes can lead to such profound disruptions, it raises the question of whether the multiverse is a stable structure or a precarious one, teetering on the edge of chaos. As we explore these ideas, we're not just imagining the risks of universe collisions, we're confronting the limits of our understanding. And in doing so, we're reminded that the universe, in all its complexity, is a place where even the most fundamental truths can be called into question. So, what happens when realities collide? The answer might be stranger than anything we've ever imagined. Time, our constant companion, always moving forward, never pausing. But what happens to time when two universes collide? Could it break, bend, or even reverse? The answer lies in the mind-bending realm of space-time, where the rules of time as we know them might no longer apply. When universes intersect, the very fabric of space-time could warp, creating effects that challenge our understanding of cause and effect. One of the most intriguing possibilities is time dilation, a phenomenon where time flows at different rates depending on the observer's perspective. In a universe collision, the immense gravitational forces at play could cause time to slow down in one region while speeding up in another, creating a patchwork of timelines that no longer align. But what if time doesn't just stretch? What if it loops? Some theories suggest that intersecting universes could create closed time-like curves where time bends back on itself, forming a loop. Imagine living in a reality where events repeat endlessly, trapped in a cosmic cycle with no beginning or end. This isn't just science fiction. It's a real possibility explored by physicists studying the behavior of space-time under extreme conditions. In a universe collision, the merging of different timelines could create these loops, leading to scenarios where the past, present, and future become indistinguishable. It's a concept that defies intuition, but in the chaos of a universe collision, intuition might not apply. Now, let's take this idea further. If time can bend or loop, could intersecting universes create portals to other realities? The idea isn't as far-fetched as it sounds. Some theories propose that the intense energy released during a universe collision could tear open wormhole shortcuts through spacetime that connect distant points in the multiverse. These wormholes could act as gateways, allowing matter, energy, or even information to travel between universes. For advanced civilizations, these portals might offer a way to escape the chaos of a collision or explore entirely new realities. But there's a catch. Traversing these portals could be incredibly dangerous. The instability of spacetime during a collision could make these wormholes unpredictable, with no guarantee of where or when they might lead. The behavior of time in a colliding universe isn't just a theoretical curiosity. It's a reminder of how fragile our perception of reality might be. In our everyday lives, time feels like a constant, unchanging force. But in the context of intersecting universes, it becomes a fluid, malleable dimension that can twist, stretch, and even shatter. This raises profound questions about our place in the cosmos. If time can change so drastically, what does that mean for our understanding of existence? Could we one day witness events that defy the linear flow of time, or even find ourselves caught in a loop where history repeats itself? As we explore these possibilities, we're not just imagining the fate of time, we're redefining what it means to exist in a universe where the rules are constantly in flux. The collision of two universes doesn't just challenge our understanding of physics, it invites us to rethink the very nature of reality itself. And in doing so, it reminds us that the cosmos is a place of infinite mystery, where even the most fundamental truths can be rewritten in an instant. What if the collision of two universes didn't just reshape reality, but opened doorways to entirely new ones? This is the tantalizing idea behind the concept of wormholes, tunnels through spacetime that could connect distant points in the multiverse. Often depicted in science fiction as shimmering gateways or swirling vortexes, wormholes have long captured our imagination. But could they be more than just a trope in movies and books? Could the immense energy released during a universe collision actually create these cosmic shortcuts, bridging the gap between realities? The answer might lie in the intersection of theoretical physics and the wild possibilities of the multiverse. To understand how wormholes might form, let's revisit the idea of spacetime as a flexible fabric. In our universe, massive objects like stars and black holes bend this fabric, creating gravitational wells. But in the chaos of a universe collision, the fabric of spacetime could be stretched, twisted, or even torn. Some theories suggest that the intense gravitational forces at play during such an event might create stable wormholes, tunnels that link two points in spacetime, effectively acting as portals between universes. These wormholes wouldn't just be shortcuts through space, they could allow travel between realities with entirely different laws of physics. But how would these portals work? Imagine stepping through a wormhole and emerging in a universe where gravity is weaker or where time flows backward. The experience would be nothing short of surreal, challenging every instinct we have about how reality operates. In science fiction, wormholes are often portrayed as sleek, glowing tunnels. Think of the iconic stargates from shows like Stargate SG-1 or the cosmic highways in Interstellar. While these depictions are dramatized, they're rooted in a kernel of scientific truth. Real wormholes, if they exist, would likely be far more chaotic, shaped by the unpredictable forces of the colliding universes that created them. The real question, though, is whether these portals could be traversed. even if wormholes were to form during a universe collision, navigating them would be no small feat. The instability of space-time during such an event could make these tunnels incredibly dangerous. One wrong step, and you might find yourself trapped in a region of space-time where the laws of physics no longer apply, or worse, where time itself ceases to have meaning. And then there's the issue of energy. Traversing a wormhole would require an immense amount of it, far beyond anything we're capable of generating today. For now, the idea remains firmly in the realm of theory, but it's a theory that continues to inspire scientists and dreamers alike. The ethical implications of such portals are equally fascinating and fraught with complexity. If humanity ever discovered a wormhole, how would we decide who gets to use it? Would it be a tool for exploration, a means of escape, or a weapon of unimaginable power? And what if the other side of the portal led to a universe with intelligent life? How would we approach first contact, knowing that our actions could ripple across realities? These questions aren't just hypothetical. They force us to confront the responsibilities that come with such profound discoveries. As we ponder the possibility of portals between universes, we're reminded that the collision of two realities isn't just a scientific event, it's a philosophical one. It challenges us to think beyond the limits of our own existence and consider the infinite possibilities of the multiverse. Whether wormholes are science fiction or science fact, they remind us that the cosmos is a place of endless wonder, where the boundaries between imagination and reality are constantly being redefined. And as we continue to explore these ideas, we're not just searching for answers, we're opening doors to new ways of seeing the universe and our place within it. The idea of stepping into another universe isn't just a scientific challenge, it's an ethical minefield. Picture this: humanity discovers a wormhole leading to a parallel reality. The excitement of exploration would be undeniable, but so too would the questions. Should we even consider entering another universe? And if we did, what responsibilities would we bear as visitors or intruders into a reality that isn't our own? These aren't just hypothetical concerns, they're dilemmas that force us to confront the moral implications of our curiosity. After all, the moment we cross that threshold, we're no longer just observers. We become participants in a reality that may not welcome our presence. One of the most pressing ethical questions is whether we have the right to interfere with another universe at all. Think about it. Even if we approach with the best intentions, our very presence could disrupt the delicate balance of that reality. What if our technology, our biology, or even our ideas introduced unintended consequences? We've seen on Earth how the introduction of foreign species or ideas can have devastating effects on ecosystems and cultures. Now, imagine that on a cosmic scale. A seemingly harmless act in another universe could trigger a chain reaction, altering its history, its evolution, or even its survival. The stakes are unimaginably high, and the burden of responsibility would be immense. But there's another side to this ethical dilemma: the potential for exploitation. If another universe harbors resources, knowledge, or even life forms that we don't have, would we be able to resist the temptation to take advantage? History is littered with examples of civilizations exploiting others in the name of progress or power. Could we truly avoid repeating those mistakes on an inter-universal scale? The risk isn't just about what we might take, it's about what we might destroy in the process. Advanced civilizations capable of traversing the multiverse would need to grapple with these questions long before they ever set foot in another reality. The ethics of exploration would have to be as carefully considered as the science behind it. This brings us to the concept of inter-universe diplomacy. If we assume that other universes harbor intelligent life, how would we approach first contact? Diplomacy on Earth is complex enough, with cultural differences, language barriers, and conflicting interests. Now, imagine trying to negotiate with a civilization that operates under entirely different laws of physics, with a worldview shaped by a reality we can barely comprehend. The potential for misunderstanding or even conflict would be enormous, yet the opportunity for collaboration could be equally profound. Sharing knowledge, resources, and perspectives across universes could lead to breakthroughs we can't even imagine. But it would require a level of humility, respect, and cooperation that humanity has rarely demonstrated on its own planet. At the heart of these ethical dilemmas is a fundamental question: what does it mean to be a responsible species in a multiverse? If we're capable of exploring other realities, do we have an obligation to protect them? Should we establish guidelines or even laws to govern how we interact with other universes? These aren't just questions for philosophers, they're challenges that advanced civilizations would need to address before taking that first step into the unknown. The answers we find could shape not just the future of humanity, but the fate of countless realities beyond our own. As we consider these ethical quandaries, we're reminded that the collision of universes isn't just a cosmic event. It's a mirror reflecting our own values, choices, and responsibilities. Whether we choose to explore, to protect, or to simply observe, the decisions we make would ripple across the multiverse, leaving a legacy that could last for eons. And in grappling with these questions, we're not just preparing for a future where universe travel is possible. We're defining what kind of explorers and what kind of species we want to be. Imagine a scenario where two civilizations, born in separate universes with entirely different laws of physics, finally make contact. What would that first conversation look like? How would beings from such vastly different realities even begin to understand one another? The idea of inter-universe diplomacy isn't just a thought experiment, it's a profound challenge that forces us to rethink how we approach communication, cooperation, and even the nature of intelligence itself. If intersecting universes could bring civilizations together, the potential for collaboration is as thrilling as it is daunting. The first hurdle would be communication. On Earth, even with shared languages and cultural frameworks, misunderstandings are common. Now, imagine trying to communicate with a civilization that perceives time differently, or one where the concept of individuality doesn't exist. Their language, if they even use one, might not rely on sound or visual symbols the way ours does. It could be based on entirely different senses or abstract concepts we can't even fathom. Establishing a common ground would require more than just translators. It would demand a revolution in how we think about meaning and expression. Some theories suggest that mathematics or fundamental physics could serve as a universal language, but even these might vary between universes. What if their version of 2 + 2 doesn't equal 4? The challenges are immense, but so are the possibilities. Beyond communication lies the question of trust. How do you build a relationship with a civilization that operates under rules you can't fully comprehend? On Earth, diplomacy often relies on shared values, mutual interests, and the ability to predict behavior based on past actions. But in a universe where the laws of physics might shift unpredictably, predicting behavior becomes nearly impossible. Would alliances be based on mutual curiosity, or would fear of the unknown drive civilizations apart? The stakes are high, and the risks of misunderstanding or even conflict are profound. Yet, the potential rewards are equally staggering. Imagine the knowledge that could be shared, the technologies that could be developed, or the cultural richness that could emerge from such a collaboration. One of the most intriguing possibilities is the blending of cultures. If civilizations from different universes could find a way to coexist, what would their combined societies look like? Could we see the emergence of hybrid art forms, philosophies, or even ways of life that transcend the boundaries of a single reality? the merging of two universes might not just be a physical event. It could be a cultural one, reshaping how civilizations think, create, and interact. This blending wouldn't be without friction, of course. Differences in values, priorities, or even perceptions of reality could lead to tension. But if navigated carefully, these differences could become strengths, offering new perspectives and solutions to problems that neither civilization could solve alone. Now let's shift our focus to the potential for new life forms. If two universes collide, could the unique combination of their physical laws give rise to something entirely new? Imagine a universe where gravity is weaker, or where time flows in loops intersecting with our own. The resulting environment might be so radically different that it sparks the evolution of life forms unlike anything we've ever seen. These beings might not just adapt to their new reality, they could thrive in it, developing unique traits and abilities that allow them to navigate the complexities of a merged universe. This raises a tantalizing question. Could intersecting universes be the birthplace of entirely new species or even new forms of intelligence? As we explore these ideas, we're reminded that the collision of universes isn't just a cosmic event, it's a catalyst for transformation. Whether it's through diplomacy, cultural exchange, or the emergence of new life, the intersection of realities challenges us to think beyond the limits of our own existence. It invites us to imagine a future where the boundaries between worlds dissolve, not just in space and time, but in the way we understand ourselves and each other. And in doing so, it doesn't just redefine the cosmos, it redefines what it means to be part of something truly infinite. What if the collision of two universes didn't just reshape the cosmos, it sparked the birth of entirely new forms of life? Imagine a reality where the blending of physical laws creates environments so unique that evolution takes on a whole new dimension. In our universe, life has adapted to a specific set of rules: gravity, the speed of light, and the chemistry of carbon. But in a merged universe, these constants could shift, opening the door to life forms that defy our imagination. Picture organisms that thrive in a world where time loops endlessly, or creatures that navigate dimensions beyond our perception. The possibilities are as limitless as the multiverse itself. One of the most fascinating aspects of this scenario is the potential for hybrid ecosystems. When two universes collide, their distinct physical laws might combine in ways that create entirely new habitats. For example, a universe with weaker gravity intersecting with ours could give rise to towering, lightweight organisms, while a universe with a different chemical makeup might produce life forms based on elements we've never encountered. These ecosystems wouldn't just be strange, they'd be revolutionary, challenging everything we think we know about biology and the conditions necessary for life. But what about evolution itself? In a merged universe, the rules of natural selection could change dramatically. The intense energy and shifting physical constants might accelerate evolution, pushing life to adapt at an unprecedented pace. Organisms that once took millions of years to evolve might develop new traits in a fraction of that time. This rapid evolution could lead to species that are not only more resilient but also more complex, capable of surviving in environments that would be deadly to life as we know it. And with the blending of multiple universes, there's even the possibility of life forms that combine traits from both realities, creating hybrid species unlike anything we've ever seen. Now consider the role of technology in such a world. If advanced civilizations exist in either of the colliding universes, they might play a direct role in shaping these new life forms. Genetic engineering, for example, could be used to create organisms specifically designed to thrive in the merged reality. These beings might possess abilities that seem almost magical to us, like the capacity to manipulate time, survive in extreme conditions, or communicate across dimensions. The line between natural evolution and technological intervention could blur, leading to a future where life is as much a product of design as it is of chance. This raises a profound question. Could we one day witness the birth of a new kind of intelligence? If life in a merged universe evolves at an accelerated rate, it's possible that sentient beings could emerge far sooner than they did in our own history. These entities might think, communicate, and perceive reality in ways we can't even begin to understand. Imagine a civilization that experiences time as a loop, or one that exists simultaneously in multiple dimensions. Their understanding of existence would be radically different from ours, challenging our assumptions about what it means to be intelligent. As we explore these possibilities, we're reminded that the collision of universes isn't just a cosmic event, it's a catalyst for transformation on every level. From the emergence of new life forms to the evolution of intelligence, the merging of realities invites us to rethink what's possible. It's a reminder that the universe, in all its complexity, is a place of endless potential where even the most unimaginable scenarios can become reality. And as we continue to push the boundaries of our understanding, we're not just observing the cosmos, we're witnessing the birth of something entirely new. What happens to technology when two universes collide? In a moment where the very fabric of reality is rewritten, the tools and systems we rely on could either become obsolete or unlock unimaginable possibilities. For advanced civilizations, the collision might present an unprecedented opportunity to harness the immense energy released during such an event. Think of it as the ultimate power source. The fusion of two universes could generate energy on a scale that dwarfs anything we've ever seen. This energy could fuel technologies far beyond our current understanding, from faster-than-light travel to devices that manipulate space-time itself. But here's the catch. Harnessing this energy would require a level of technological sophistication that might only exist in the most advanced civilizations. On the flip side, the chaos of a universe collision could render existing technology useless. Imagine the infrastructure of a highly advanced society: communication networks, transportation systems, energy grids, all disrupted by the sudden shift in physical laws. What happens to a starship designed to navigate the laws of one universe when those laws no longer apply? Or to a quantum computer that relies on the stability of space-time to function? The collision could create a technological blackout, forcing civilizations to rebuild from the ground up in a reality where the rules have fundamentally changed. Yet, even in the face of such upheaval, the potential for breakthroughs is staggering. The merging of two universes could lead to entirely new forms of energy, ones that we can't even begin to conceptualize. For instance, what if the collision created a new type of particle or force that could be harnessed for unlimited power? Or what if it revealed a way to tap into the energy of dark matter, a mysterious substance that makes up most of the universe's mass but has eluded our understanding? The possibilities are as vast as they are tantalizing. Transportation could also undergo a radical transformation. If wormholes or portals between universes were to form, they could revolutionize how civilizations move through space and even time. Imagine a network of cosmic highways connecting not just distant points in a single universe but entire realities. This wouldn't just make interstellar travel possible, it could make inter-universal travel a reality. But as with any breakthrough, there are risks. Navigating these portals would require an understanding of the new laws governing the merged universe, and a single misstep could have catastrophic consequences. Communication, too, could be transformed. In a merged universe, traditional methods of sending information might no longer work, but the collision could also create new ways to transmit data, perhaps through quantum entanglement across realities or via channels that don't rely on electromagnetic waves. Advanced civilizations might develop technologies that allow them to communicate instantaneously across vast distances, or even across different timelines. The implications for diplomacy, trade, and cultural exchange would be profound, reshaping how civilizations interact on a cosmic scale. Now, let's take this one step further. Could intersecting universes hold the key to unlocking the secrets of dark matter? This elusive substance, which makes up over 80% of the universe's mass, has puzzled scientists for decades. If a universe collision altered the fundamental constants of nature, it could provide a unique opportunity to study dark matter in ways that were previously impossible. The immense energy released during the collision might even create conditions where dark matter becomes observable, shedding light on one of the greatest mysteries in modern physics. As we explore these ideas, we're reminded that the collision of universes isn't just a cataclysmic event, it's a crucible of innovation. Whether it leads to technological chaos or groundbreaking advancements, the merging of realities challenges us to rethink what's possible. And in doing so, it doesn't just change the future of technology, it changes the future of existence itself. What if the key to understanding universe collisions lies in one of the greatest mysteries of the cosmos, dark matter? This elusive substance, which makes up over 80% of the universe's mass, has long baffled scientists. We can't see it, touch it, or even detect it directly, yet its gravitational effects are undeniable. But here's where it gets even more intriguing. Could dark matter play a crucial role in the collision of universes? Some theories suggest that dark matter might act as a kind of cosmic glue, holding the fabric of reality together in ways we're only beginning to understand. And if that's true, it could be the very thing that allows universes to intersect. To grasp this idea, let's think about dark matter as a hidden scaffold, stretching across the universe and beyond. In the context of the multiverse, this scaffold might extend into higher dimensions, connecting universes that would otherwise remain isolated. If two universes were to collide, dark matter could serve as the bridge, guiding their interaction and shaping the outcome. Imagine it as a network of invisible threads, weaving through the fabric of space-time and enabling realities to merge. This isn't just a poetic metaphor, it's a hypothesis that could explain how universe collisions occur and why they might follow certain patterns. But how could we ever prove this? Studying dark matter is already a monumental challenge, given its invisible nature. However, if dark matter does play a role in universe collisions, it might leave behind subtle clues. For instance, the energy released during such an event could interact with dark matter in ways that produce detectable signals. These signals might take the form of unusual gravitational waves, bursts of high-energy radiation, or even anomalies in the cosmic microwave background. By studying these phenomena, scientists could piece together the role dark matter plays in the collision process, shedding light on both the nature of dark matter and the mechanics of universe intersections. Now, let's consider another cosmic heavyweight that could be involved in these collisions: black holes. These mysterious objects, with their immense gravitational pull, are already known to warp spacetime in extreme ways. Could they also act as catalysts for universe collisions? Some theories propose that black holes, especially supermassive ones, might serve as focal points where universes intersect. Their immense gravity could create ripples in higher dimensional space, pulling universes close together until they collide. In this scenario, black holes wouldn't just be destructive forces, they'd be cosmic crossroads where realities meet and merge. The interplay between dark matter and black holes adds another layer of complexity to this puzzle. If dark matter acts as a bridge between universes, black holes could be the anchors holding these bridges in place. Together, they might form a kind of cosmic infrastructure that facilitates the intersection of realities. This idea isn't just speculative, it's rooted in mathematical models that explore the behavior of spacetime under extreme conditions. While we're still far from confirming these theories, they offer a tantalizing glimpse into the hidden forces that might shape the multiverse. As we explore these possibilities, one thing becomes clear. The collision of universes isn't just a dramatic event, it's a window into the deepest mysteries of existence. By studying dark matter and black holes, we're not just uncovering the mechanics of universe collisions, we're redefining our understanding of reality itself. And in doing so, we're reminded that the cosmos is a place of endless wonder, where even the most elusive forces can hold the key to unlocking the secrets of the multiverse. So, what if dark matter is the hidden thread that ties it all together? The answer might just change everything we thought we knew. What if black holes aren't just cosmic vacuums sucking in everything around them? What if they're gateways to other universes? This mind-bending idea has been a cornerstone of theoretical physics for decades, suggesting that these enigmatic objects might be more than just destroyers of light and matter. Instead, they could be portals connecting our universe to entirely different regions of space-time, or even to entirely different realities. To understand how this might work, let's take a closer look at what black holes really are and why they've captured the imagination of scientists and dreamers alike. At their core, black holes are regions of space-time where gravity is so intense that nothing, not even light, can escape their pull. But what happens to all that matter and energy that gets sucked in? Some theories propose that it doesn't just vanish. It might travel through a tunnel-like structure called a wormhole, emerging in another part of the universe or even in a completely different universe. Picture a black hole as a cosmic drain, but instead of leading to a sewer, it connects to a vast, uncharted ocean of possibilities. This ocean could be another universe with its own stars, galaxies, and even life. The concept of black holes as gateways isn't just science fiction, it's rooted in the mathematics of general relativity. Einstein's equations suggest that the intense gravity of a black hole could warp spacetime to such an extreme degree that it creates a bridge or wormhole to another region of spacetime. These hypothetical tunnels, often referred to as Einstein-Rosen bridges, could theoretically allow travel between distant points in the universe or even between universes. The catch: we have no idea what's on the other side or whether anything could survive the journey. The intense gravitational forces near a black hole's singularity would likely tear apart anything that ventured too close, making the idea of traversing a black hole gateway a perilous proposition. To make this concept more tangible, let's use a visual metaphor. Imagine spacetime as a sheet of paper. If you poke a hole in the paper and fold it so that 2 points touch, you create a shortcut between them. A black hole could act like that hole, bending spacetime so drastically that it connects 2 distant regions, or even 2 separate sheets of paper representing different universes. This folding of spacetime isn't just a theoretical curiosity. It's a plausible explanation for how black holes might serve as cosmic gateways. But here's the twist: if 2 universes are connected in this way, what happens if one of them collapses or changes? Could the gateway become unstable, leading to catastrophic consequences? This brings us to a chilling possibility. Could intersecting universes connected by black holes lead to the end of everything? If 2 universes were to collide or merge through these gateways, the resulting chaos could be unimaginable. The energy released from such an event might trigger a chain reaction, destabilizing both realities and tearing apart the very fabric of existence. Alternatively, the collision could create a new hybrid universe where the laws of physics are rewritten in real time. The outcome is impossible to predict, but one thing is certain: the stakes couldn't be higher. As we explore these ideas, we're reminded that black holes are more than just cosmic curiosities. They're windows into the deepest mysteries of the universe. Whether they're gateways to other realities or simply the remnants of collapsed stars, they challenge us to think beyond the limits of our understanding. And in doing so, they invite us to imagine a cosmos that's far stranger, more interconnected, and more awe-inspiring than we've ever dared to dream. So, could black holes be the keys to unlocking the secrets of the multiverse? The answer might just redefine our place in the grand tapestry of existence. What if the collision of two universes wasn't just a cosmic event? What if it was the end of everything? The apocalyptic potential of universe collisions is a scenario that's as terrifying as it is fascinating. Picture this: two universes, each with their own unique laws of physics, hurtling toward one another. The moment they collide, the energy released could be catastrophic, ripping apart the very fabric of space-time. Stars, planets, and entire galaxies could be obliterated in an instant, leaving behind nothing but a chaotic void. This isn't just science fiction. It's a possibility that some of the most cutting-edge theories in physics are beginning to explore. One of the most dramatic outcomes of a universe collision is the concept of the Big Crunch. Imagine a scenario where the collision triggers a reversal of the universe's expansion. Instead of galaxies drifting apart, they'd begin to collapse inward, pulled by the immense gravitational forces of the merging universes. Over time, everything, stars, planets, even atoms, would be compressed into an infinitesimally small point, a singularity. This would mark the end of both universes, a cosmic doomsday where all matter and energy are crushed into oblivion. It's a chilling thought, but one that's rooted in the mathematics of general relativity and the behavior of space-time under extreme conditions. But the Big Crunch isn't the only apocalyptic possibility. Another theory, known as the heat death of the universe, paints a different but equally bleak picture. In this scenario, the collision would release so much energy that it disrupts the delicate balance of the universe's expansion. Over time, the universe would cool and expand indefinitely, with stars burning out and matter decaying into radiation. The end result would be a cold, dark, and lifeless cosmos where no new stars are born and no energy is left to sustain life. It's a slow, quiet end, a far cry from the violent destruction of the Big Crunch, but no less final. Despite these dire predictions, not all universe collisions lead to doom. Some theories suggest that such events could also be a source of renewal. Imagine a scenario where the collision doesn't destroy both universes but instead creates something entirely new. The immense energy released could spark a new Big Bang, birthing a fresh universe with its own set of physical laws and constants. This idea, often referred to as the Cyclic universe model, suggests that the end of one universe could be the beginning of another, creating a cycle of birth, death, and rebirth that stretches across eternity. To make this idea more tangible, think of a forest fire. While it destroys the existing ecosystem, it also clears the way for new growth, creating opportunities for new life to emerge. In the same way, a universe collision could be both destructive and creative, wiping out old realities while giving rise to new ones. This duality challenges us to think beyond the idea of an absolute end and consider the possibility of transformation, a cosmic reset that reshapes existence itself. The question, then, isn't just whether universe collisions could lead to destruction, it's whether they could also be a force for renewal. Could the end of one universe pave the way for the birth of another, creating a cycle of cosmic evolution that transcends time and space? As we explore these ideas, we're reminded that the universe, in all its vastness, is a place of endless possibility. Whether it's the fiery end of a Big Crunch or the quiet emergence of a new reality, the collision of universes challenges us to rethink our understanding of existence itself. And in doing so, it invites us to imagine a cosmos where even the most catastrophic events hold the seeds of new beginnings. What if the collision of two universes wasn't the end of everything, but the beginning of something entirely new? While the idea of universe collisions often conjures images of cosmic destruction, there's another side to this story, one of renewal and rebirth. Think of it as nature's way of hitting the reset button, where chaos gives way to creation and destruction paves the path for new beginnings. The immense energy released during such an event could act as a cosmic spark, igniting the birth of new stars, galaxies, and even entirely new universes. It's a concept that challenges our understanding of existence, suggesting that the end of one reality might be the dawn of another. This idea aligns closely with cyclical models of the cosmos, which propose that the universe undergoes endless cycles of birth, death, and rebirth. In these models, the Big Bang isn't a one-time event but part of an ongoing process where universes expand, contract, and collide, creating a perpetual cycle of renewal. Imagine it as a cosmic dance where universes move in rhythm with one another, their collisions not marking the end but the start of a new chapter. This cyclical view offers a profound perspective on the nature of existence, suggesting that even the most catastrophic events can lead to something beautiful and transformative. But how could a universe collision lead to renewal? The answer lies in the immense energy released during the event. When two universes collide, their combined forces could generate enough energy to trigger a new Big Bang, birthing a fresh universe with its own unique laws of physics. This isn't just speculation, it's a theory supported by mathematical models that explore the behavior of space-time under extreme conditions. The collision could create a cosmic forge, where the intense heat and pressure give rise to new forms of matter and energy, setting the stage for a new reality to emerge. Consider this analogy: a forest fire. While it destroys the existing ecosystem, it also clears the way for new growth, creating opportunities for new life to flourish. In the same way, a universe collision could be both destructive and creative, wiping out old realities while giving rise to new ones. This duality challenges us to think beyond the idea of an absolute end and consider the possibility of transformation, a cosmic reset that reshapes existence itself. The collision wouldn't just destroy, it would also create, offering a glimpse into the infinite potential of the multiverse. Now, let's take this idea one step further. If universe collisions can lead to renewal, could they also reveal the ultimate nature of reality? Some theories suggest that these events might act as windows into the fundamental laws that govern existence. By studying the aftermath of a collision, scientists could uncover clues about the nature of space-time, the origins of the universe, and even the possibility of other realities. It's a tantalizing thought. The collision of universes might not just reshape reality, it could help us understand it on a deeper level. As we explore these ideas, we're reminded that the universe, in all its vastness, is a place of endless possibility. Whether it's the fiery destruction of a big crunch or the quiet emergence of a new reality, the collision of universes challenges us to rethink our understanding of existence. And in doing so, it invites us to imagine a cosmos where even the most catastrophic events hold the seeds of new beginnings. Could intersecting universes reveal the ultimate nature of reality? The answer might just change everything we thought we knew. What if the reality we experience every day isn't real at all? What if it's a simulation? This is the provocative idea that's been gaining traction in both scientific and philosophical circles, and it's one that takes on a whole new dimension when we consider the possibility of intersecting universes. If our universe is just one of many, and if these universes can collide or overlap, could such events reveal the underlying code of existence? Could the fabric of reality itself be exposed, showing us the strings being pulled behind the scenes? It's a question that ties into one of the most debated theories of our time, the simulation hypothesis. At its core, the simulation hypothesis suggests that our reality might be an artificial construct, a kind of advanced computer program created by an intelligent civilization. Proponents of this idea argue that if a civilization could develop technology sophisticated enough to simulate entire universes, it's possible that we're living in one of those simulations. Now add the concept of intersecting universes to the mix. If two simulated realities were to collide, the resulting chaos could create glitches or anomalies, moments where the code of the simulation becomes visible. Think of it as a cosmic error message revealing the digital scaffolding that holds our reality together. But how could we ever detect such a glitch? One possibility lies in the study of quantum mechanics. At the smallest scales, particles behave in strange and unpredictable ways, almost as if they're following a set of programmed rules rather than natural laws. If intersecting universes were to disrupt these rules, it could create observable anomalies like particles behaving in ways that defy our understanding of physics. These anomalies might serve as evidence that we're living in a simulated reality, where the collision of universes has exposed the underlying framework of existence. This idea isn't just a thought experiment, it's grounded in cutting-edge research. Scientists are already exploring ways to test the simulation hypothesis, using experiments that probe the limits of our understanding of reality. For example, some researchers are looking for patterns or pixels in the fabric of space-time that might indicate we're living in a simulation. Others are studying the behavior of particles at the quantum level, searching for inconsistencies that could point to a programmed reality. If intersecting universes were to create such inconsistencies, it could provide the evidence we need to confirm or debunk the simulation hypothesis. Now, let's shift our focus to the role of consciousness in this scenario. If reality is a simulation, what does that mean for our perception of it? Some theories suggest that consciousness itself might be a product of the simulation, a kind of programmed experience designed to mimic the feeling of being alive. But if intersecting universes can disrupt the simulation, could they also alter our consciousness? Imagine a scenario where the collision of two realities creates a shift in perception, allowing us to see beyond the confines of our programmed existence. It's a tantalizing thought, one that blurs the line between science and philosophy. The concept of intersecting universes also raises questions about the nature of free will in a simulated reality. If our actions are governed by a set of programmed rules, do we truly have the ability to make choices, or are we merely following a script, our every decision predetermined by the code of the simulation? These are questions that have puzzled philosophers for centuries, but they take on new urgency in the context of a multiverse. If multiple simulated realities exist, each with its own set of rules, the collision of universes could create a hybrid reality where the nature of free will is called into question. As we explore these ideas, one thing becomes clear: the intersection of universes isn't just a physical event, it's a philosophical one. It challenges us to rethink our understanding of reality, consciousness, and even our place in the cosmos. Whether we're living in a simulation or not, the possibility of intersecting universes invites us to imagine a reality that's far more complex, interconnected, and mysterious than we've ever dared to dream. And in doing so, it doesn't just change how we see the universe, it changes how we see ourselves. What if your consciousness isn't confined to a single reality, but stretches across multiple universes? This is the mind-bending idea at the heart of consciousness in a multiverse. Imagine that every decision you've ever made or didn't make exists somewhere else in a parallel universe. In one reality, you might be a musician, in another, a scientist. But here's the twist: what if your awareness isn't limited to just one of these versions? What if your consciousness could somehow connect with alternate versions of yourself, living out different lives in different realities? The concept of intersecting universes takes this idea even further, suggesting that these alternate versions might not just exist in isolation. They could overlap, blend, or even communicate. To grasp this concept, let's think about consciousness as a kind of thread weaving through the fabric of multiple realities. In our current understanding, consciousness is tied to the physical brain, a product of neural activity in this specific universe. But what if consciousness is more fundamental than that? What if it's a property of the multiverse itself, able to exist across different realities? This idea, often referred to as the multiverse theory of consciousness, suggests that your sense of self isn't confined to one timeline. It's a collection of experiences across countless realities, each one contributing to a larger, more complex version of you. Now consider what happens when two universes intersect. If consciousness can exist across multiple realities, the collision of universes could create a bridge, allowing these alternate versions of yourself to connect. Imagine a moment where your awareness merges with another version of you, one who made different choices, lived a different life, even developed a different personality. What would that feel like? Would you gain new memories, new skills, or even new emotions? The implications are staggering, forcing us to rethink not just identity, but the very nature of self-awareness. This brings us to a profound question. If consciousness exists across multiple realities, what does that mean for free will? On one hand, it suggests that every possible choice you could make has been made somewhere in the multiverse. On the other hand, it raises the possibility that your consciousness could actively choose which reality to inhabit, shifting your awareness between versions of yourself. It's a concept that blurs the line between determinism and free will, suggesting that while every path exists, you still have the power to navigate them. But what about the practical implications? Could intersecting universes allow us to access alternate versions of ourselves in a tangible way? Some theories propose that advanced civilizations might develop technologies to harness this connection, creating devices that allow individuals to communicate with or even inhabit their alternate selves. Imagine a future where you could step into a machine and experience life as another version of you, one who took a different path. It's a thrilling thought, but also a deeply unsettling one. How would you reconcile the differences between these versions? Would you still feel like you, or would the experience fracture your sense of identity? As we explore these ideas, one thing becomes clear. The intersection of universes doesn't just challenge our understanding of reality, it challenges our understanding of ourselves. If consciousness can exist across multiple realities, it suggests that we're far more complex, interconnected, and multidimensional than we've ever imagined. And in grappling with these questions, we're not just exploring the nature of existence, we're exploring the nature of being. Could intersecting universes lead to new dimensions of consciousness? The answer might just redefine what it means to be you. What if the key to understanding universe collisions lies not in the three dimensions we experience every day, but in dimensions beyond our perception? To grasp this idea, let's step into the mind-bending world of higher dimensions. We're all familiar with the three spatial dimensions: length, width, and height that define the space around us. But what if there's a fourth dimension, or even more, that we can't see or feel? These hidden dimensions might hold the answers to how universes could intersect, collide, or even overlap. And while they sound like science fiction, they're rooted in serious scientific theories that could reshape our understanding of reality. Think of higher dimensions as layers of a cosmic onion, each one stacked on top of the next but invisible to us. In the context of universe collisions, these dimensions could act as bridges, connecting realities that would otherwise remain separate. String theory, for example, suggests that our universe might be a three-dimensional brane floating in a higher dimensional space, like a sheet of paper drifting in a vast, unseen ocean. If another brane, another universe, were to drift close enough, they could touch or even merge, creating a collision that ripples through both realities. This isn't just a wild idea. It's a framework that physicists use to explore how universes might interact in ways we can't directly observe. To make this more relatable, let's use an analogy. Imagine you're an ant living on the surface of a large balloon. To you, the balloon is your entire world, a two-dimensional plane where you can move forward, backward, left, or right. But what if another balloon, representing another universe, were to float close to yours and touch it? From your perspective, it might seem like a sudden, inexplicable event, something appearing out of nowhere. But in reality, the collision happened in a higher dimension, one you couldn't see. This is how higher dimensions might facilitate universe collisions, by providing a hidden stage where realities can interact without us even realizing it. Now, let's take this a step further. Could intersecting universes reveal the existence of these higher dimensions? The answer might lie in the subtle clues left behind by such an event. For instance, if two universes collided in a higher dimension, the energy released could create ripples in our own reality, ripples that we might detect as anomalies in the fabric of space-time. These anomalies could take the form of strange gravitational waves, unusual patterns in the cosmic microwave background, or even unexpected shifts in the behavior of particles. By studying these clues, scientists could piece together the existence of dimensions beyond our own, opening a window into a reality that's far more complex than we've ever imagined. But why does this matter? Understanding higher dimensions isn't just an academic exercise. It's a key to unlocking the mysteries of the multiverse. If higher dimensions exist, they could explain not only how universes collide, but also why our universe has the specific physical laws and constants that it does. They might even hold the key to questions about the origins of the cosmos, the nature of dark matter, or the ultimate fate of reality itself. In other words, higher dimensions aren't just a curiosity, they're a gateway to understanding the deepest secrets of existence. As we explore these ideas, we're reminded that the universe is far stranger and more interconnected than we've ever dared to imagine. The collision of universes isn't just a dramatic event, it's a glimpse into a reality that transcends the limits of our perception. And in grappling with these concepts, we're not just expanding our understanding of the cosmos, we're redefining what it means to exist in a universe that's infinitely more complex than we've ever thought possible. Could higher dimensions be the missing piece of the puzzle? The answer might just change everything we thought we knew. What if the collision of two universes didn't just reshape reality? It revealed layers of existence we never even knew existed. This is the tantalizing idea behind the concept of higher dimensions, realms that lie beyond the three spatial dimensions we experience every day. While length, width, and height define the world around us, theoretical physics suggests there could be more, dimensions that are hidden from our perception but might hold the key to understanding the multiverse. These extra dimensions aren't just abstract ideas, they're a cornerstone of theories like string theory, which proposes that our universe is a three-dimensional brane floating in a higher dimensional space. If this is true, then the collision of universes could be happening in dimensions we can't see, creating ripples that affect our reality in profound ways. Imagine higher dimensions as a kind of cosmic scaffolding, a framework that connects and supports multiple universes. In this view, our universe might be just one of many branes drifting in a vast, unseen ocean of higher dimensional space. When two branes or universes collide, the interaction could occur in these hidden dimensions, leaving behind clues that we might detect in our own reality. These clues could take the form of strange gravitational waves, anomalies in the cosmic microwave background, or even unexpected shifts in the behavior of particles. By studying these phenomena, scientists could begin to piece together the existence of dimensions beyond our own, opening a window into a reality that's far more complex than we've ever imagined. But why should we care about higher dimensions? The answer lies in their potential to revolutionize our understanding of the cosmos. If higher dimensions exist, they could explain not only how universes collide, but also why our universe has the specific physical laws and constants that it does. For example, the force of gravity might appear weaker in our universe because it's leaking into higher dimensions, diluting its strength. Or the existence of dark matter, that mysterious substance that makes up most of the universe's mass, might be tied to particles that exist in these hidden dimensions. By uncovering the role of higher dimensions, we could unlock some of the greatest mysteries in modern physics. Now, let's take this idea a step further. Could intersecting universes not only reveal higher dimensions but also lead us to the discovery of alien life? If other universes exist, it's possible that some of them harbor life forms that have evolved under entirely different physical laws. These beings might exist in dimensions we can't perceive, making them invisible to us until a collision brings their reality into contact with ours. The energy released during such an event could create anomalies that serve as signals, pointing us toward the existence of life in other dimensions. Imagine detecting a pattern in gravitational waves or cosmic radiation that suggests the presence of an advanced civilization, one that exists in a reality parallel to our own. The implications would be staggering, not just for science but for our understanding of life itself. The idea of higher dimensions challenges us to think beyond the limits of our perception and consider the possibility that reality is far more layered and interconnected than we've ever imagined. It's a concept that bridges the gap between science and imagination, inviting us to explore the unknown in ways that could redefine our place in the cosmos. And as we delve deeper into these ideas, we're reminded that the universe is a place of endless wonder, where even the most elusive dimensions might hold the key to unlocking the secrets of existence. So, could intersecting universes lead us to the discovery of alien life? The answer might just change everything we thought we knew about reality and our place within it. What if the collision of two universes didn't just reshape reality? It brought us face to face with life from another reality entirely. The idea of first contact with alien life has long fascinated us, but what if those aliens weren't just from another planet but from another universe? Imagine beings that evolved under entirely different physical laws, with minds and bodies shaped by a reality where time, space, and matter behave in ways we can't even comprehend. A meeting like this wouldn't just be a first contact, it would be a first encounter of an entirely new kind, one that would challenge our understanding of life, intelligence, and existence itself. The first hurdle in such a meeting would be communication. On Earth, even when we encounter cultures vastly different from our own, we share a common framework of reality. We breathe the same air, experience the same flow of time, and perceive the same three dimensions. But life from another universe might not share any of these things. Their language, assuming they have one, could be based on senses we don't possess or concepts we can't even imagine. How do you communicate with a being that perceives time as a loop or exists in dimensions beyond our perception? Traditional methods of communication, like sound or visual symbols, might be meaningless to them. Instead, we'd need to find a universal language, perhaps rooted in mathematics or fundamental physics, to bridge the gap between realities. But communication is just the beginning. Understanding each other's perspectives would be an even greater challenge. If their universe operates under different physical laws, their very way of thinking could be alien to us. Concepts like individuality, linear time, or even cause and effect might not apply to them. Their art, technology, and philosophy could be so different that they defy human comprehension. Imagine trying to explain love to a being that doesn't experience emotions, or sharing our history with a species that perceives time as a series of overlapping loops. These cultural and cognitive differences could make mutual understanding seem impossible, but they could also be a source of profound discovery. Despite these challenges, the potential for shared knowledge is staggering. If we could find a way to communicate, the exchange of ideas between universes could lead to breakthroughs we can't even imagine. Their technology might be based on principles we've never considered, offering solutions to problems like energy scarcity or interstellar travel. Their understanding of the cosmos could reveal new dimensions of reality, reshaping our science and philosophy. And their perspective on existence itself could challenge us to rethink what it means to be alive, to think, and to connect with others. The collision of universes wouldn't just be a meeting of minds, it could be a meeting of worldviews, each one enriching the other in ways we can't yet predict. Now, let's consider the ethical implications of such an encounter. If we were to meet life from another universe, how should we approach them? Would we seek to dominate, collaborate, or simply observe? History has shown us that first contact between civilizations rarely goes smoothly, even when both sides share the same reality. With beings from another universe, the stakes would be even higher. Their very existence could challenge our assumptions about life and its place in the cosmos. Would we treat them as equals, or would their alien nature lead to fear and misunderstanding? These questions aren't just academic, they're a reminder that the collision of universes isn't just a physical event, it's a moral and philosophical one. As we explore these ideas, one thing becomes clear. The collision of universes isn't just about the meeting of matter and energy, it's about the meeting of minds. It challenges us to think beyond the limits of our own reality and consider the possibility that life, in all its forms, might be far more diverse and interconnected than we've ever imagined. And in doing so, it invites us to imagine a future where the boundaries between worlds dissolve, not just in space and time, but in the way we understand ourselves and each other. Could intersecting universes lead to the most profound first contact in history? The answer might just redefine what it means to be human and what it means to share the cosmos with others. What if the collision of two universes didn't just reshape the cosmos, it sparked an unprecedented exchange of knowledge? Imagine civilizations from separate realities, each with their own unique understanding of science, art, and philosophy, coming together to share what they've learned. The potential for mutual growth is staggering. In one universe, a civilization might have mastered the art of manipulating space-time, while in another, they've unlocked the secrets of consciousness itself. What could happen if these worlds combined their knowledge? It's a scenario that challenges us to think beyond the limits of our own reality and consider the transformative power of shared understanding. The exchange of technology alone could revolutionize entire civilizations. Picture a universe where energy is harnessed from dark matter, meeting another where time itself is a resource to be mined. If these technologies were shared, the result could be innovations that transcend the boundaries of both realities. For example, a device that manipulates gravity could be combined with a machine that traverses time, creating a tool that allows travel not just through space, but across the very fabric of existence. The possibilities are endless, limited only by the creativity and ingenuity of the civilizations involved. But it's not just technology that could be shared. Philosophy and art, the very essence of how civilizations make sense of their existence, could also flow between universes. Imagine a society that views time as cyclical, sharing its poetry with one that perceives time as linear. Their art forms, shaped by such fundamentally different worldviews, could inspire entirely new ways of thinking and creating. The blending of these perspectives might lead to a renaissance of ideas where the boundaries between realities dissolve not just physically but culturally. It's a vision of unity that transcends the limits of individual universes, creating a tapestry of thought as rich and diverse as the multiverse itself. However, this exchange wouldn't come without challenges. The very differences that make such a collaboration so exciting could also create barriers. How do you translate a concept that exists in one universe but has no equivalent in another? What happens when the laws of physics that govern one civilization's technology are incompatible with another's? These obstacles aren't insurmountable, but they require a level of creativity and open-mindedness that pushes both civilizations to grow. The process of overcoming these challenges could, in itself, become a catalyst for innovation and mutual understanding. Now, let's take this idea a step further. Could the exchange of knowledge between universes lead to something even greater, the unification of all realities? If civilizations from multiple universes were to come together, sharing not just technology and ideas but their very understanding of existence, could they create a unified framework that transcends individual realities? It's a bold vision, one where the multiverse isn't just a collection of isolated worlds but a connected network, bound together by shared knowledge and mutual respect. This unification wouldn't erase the unique qualities of each universe. Instead, it would celebrate them, creating a cosmos that's richer and more interconnected than ever before. As we explore these possibilities, we're reminded that the collision of universes isn't just a physical event. It's an opportunity for growth, connection, and discovery. Whether it's through the exchange of technology, the blending of philosophies, or the unification of realities, the meeting of worlds challenges us to imagine a future where the boundaries between universes dissolve, not just in space and time, but in the way we understand and connect with one another. Could intersecting universes lead to the greatest collaboration in history? The answer might just redefine what it means to be part of something truly infinite. What if the collision of two universes wasn't the end of their individual identities, but the beginning of something greater, a unified reality? This is the bold idea behind the concept of cosmic unification, where intersecting universes merge into a single, harmonious existence. Picture it as a cosmic symphony where the distinct notes of each universe blend together to create a richer, more complex melody. But what would this unification look like? Would it bring balance and harmony, or would it spark new conflicts as two vastly different realities try to coexist? The answer lies in the delicate interplay of their physical laws, cultures, and histories. At the heart of this idea is the notion of cosmic oneness, a state where the boundaries between universes dissolve, creating a shared reality that transcends individual differences. In this unified cosmos, the laws of physics might harmonize, blending the unique properties of each universe into a single, cohesive framework. Time, space, and matter could behave in entirely new ways, creating a reality that's more complex and interconnected than anything we've ever known. But achieving this harmony wouldn't be easy. The process of unification could be fraught with challenges, as the distinct rules and constants of each universe clash and merge. It's a delicate dance where the stakes are nothing less than the survival of both realities. One of the most fascinating possibilities is the emergence of a hybrid reality, where the best aspects of both universes are preserved. Imagine a world where the strengths of one universe, like advanced technology or unique forms of energy, combine with the cultural richness or philosophical depth of another. This blending could lead to a renaissance of ideas, where civilizations from both realities collaborate to create something entirely new. But this isn't just about physical laws or technological advancements. It's about the potential for a shared understanding of existence. A unified cosmos might offer a deeper insight into the nature of reality, one that transcends the limits of individual perspectives. However, unification isn't without its risks. When two realities collide, the potential for conflict is just as real as the potential for harmony. Differences in values, priorities, or even fundamental beliefs could create tension as civilizations struggle to reconcile their worldviews. What happens when a universe that values individuality meets one that prioritizes collective existence, or when a civilization that sees time as linear encounters one that perceives it as cyclical? These aren't just philosophical questions, they're practical challenges that could shape the future of a unified cosmos. The key to overcoming these conflicts lies in mutual respect and a willingness to embrace the unknown. Now, let's shift our focus to the role of human imagination in understanding these theories. The idea of intersecting universes and cosmic unification pushes the boundaries of what we can comprehend, challenging us to think beyond the limits of our own reality. It's a reminder that science and imagination aren't opposites, they're partners in the quest for knowledge. Without imagination, we'd never conceive of theories like the multiverse or cosmic unification. But without science, these ideas would remain pure fantasy. Together, they allow us to explore the deepest mysteries of existence, from the origins of the cosmos to the ultimate fate of reality. As we ponder the unification of universes, we're reminded that the cosmos is a place of endless possibility. Whether it leads to harmony or conflict, the merging of realities invites us to imagine a future where the boundaries between worlds dissolve, creating a shared existence that's richer and more interconnected than ever before. And in doing so, it challenges us to rethink not just the nature of the universe, but our place within it. Could intersecting universes lead to a cosmic oneness? The answer might just redefine what it means to exist in a reality that's infinitely more complex than we've ever imagined. The human mind is a remarkable tool, capable of envisioning realities far beyond the tangible world we experience every day. It's this power of imagination that has propelled us to explore bold theories like universe collisions, ideas that stretch the boundaries of what we consider possible. From the earliest myths of creation to the cutting-edge equations of theoretical physics, imagination has been the spark that ignites our curiosity and drives us to ask the biggest questions: what lies beyond our universe? What happens when realities collide? These aren't just flights of fancy, they're the seeds of scientific discovery and philosophical inquiry. Creativity plays a crucial role in both science and philosophy, serving as the bridge between what we know and what we dream. In science, it allows us to hypothesize about phenomena we can't yet observe, like the collision of universes or the existence of higher dimensions. In philosophy, it challenges us to rethink our assumptions about existence, identity, and the nature of reality itself. Without imagination, we'd never have conceived of the multiverse string theory or the idea that our universe might be just one of many. It's this blend of creativity and rigor that pushes the limits of thought, transforming wild ideas into testable theories. But how close are we to proving these theories? The answer lies in the delicate balance between imagination and evidence. While we can't yet observe universe collisions directly, scientists are using advanced tools like gravitational wave detectors and particle accelerators to gather clues. These instruments allow us to test predictions derived from imaginative theories, bringing us closer to understanding whether these cosmic events are possible. At the same time, the very act of imagining these scenarios pushes us to develop new technologies and methods, expanding our ability to explore the unknown. Imagination also reminds us that science isn't just about facts and figures, it's about wonder. It's about looking at the night sky and wondering what lies beyond the stars, or pondering the mysteries of dark matter and the origins of the cosmos. This sense of wonder isn't just inspiring, it's essential. It drives us to keep asking questions, to keep pushing the boundaries of what we know, and to remain open to possibilities that might seem impossible today. As we reflect on the role of imagination in exploring universe collisions, we're reminded of its power to transform not just our understanding of the cosmos, but our place within it. These theories challenge us to think beyond the limits of our own reality, to imagine a multiverse that's richer, more complex, and more interconnected than we've ever dared to dream. And in doing so, they invite us to see ourselves not just as passive observers of the universe, but as active participants in its unfolding story. So, how close are we to proving these theories? The journey is just as important as the destination, and imagination will continue to light the way. What if the key to unlocking the secrets of intersecting universes is closer than we think? While the idea of multiverses and universe collisions might sound like science fiction, scientists around the world are working tirelessly to turn these bold theories into testable science. At the forefront of this effort are groundbreaking experiments like the Large Hadron Collider, or LHC, a massive particle accelerator buried deep beneath the border of France and Switzerland. This colossal machine smashes particles together at nearly the speed of light, recreating conditions similar to those just moments after the Big Bang. But here's the fascinating part. The LHC isn't just probing the origins of our universe, it's searching for clues that could hint at the existence of other realities. So, how does a particle accelerator help us understand multiverses? One of the key theories being tested is string theory, which suggests that our universe might be just one of many branes floating in a higher dimensional space. If these branes exist, they could occasionally collide, sparking events like the Big Bang. The LHC is designed to detect the tiniest hints of these higher dimensions, such as unusual energy patterns or particles that behave in unexpected ways. While we haven't found definitive proof yet, the results so far have been tantalizing, with some experiments revealing anomalies that could point to phenomena beyond our current understanding of physics. But the LHC isn't the only tool in the cosmic detectives kit. Gravitational wave detectors like LIGO and Virgo are also playing a crucial role in the search for evidence. These incredibly sensitive instruments listen for ripples in spacetime caused by massive cosmic events, such as black hole mergers or neutron star collisions. If two universes were to collide, the energy released could send gravitational waves rippling through our reality, leaving behind a signature that these detectors might one day pick up. It's like listening for the echoes of a cosmic crash hidden in the faint whispers of spacetime itself. Despite these promising tools, the search for evidence of multiverses and universe collisions is no easy task. One of the biggest challenges scientists face is the sheer scale of what they're trying to detect. The energy required to probe higher dimensions or observe universe collisions is far beyond what we can currently generate. Even the LHC, with its immense power, can only recreate a fraction of the conditions needed to test these theories. And then there's the problem of interpretation. When an experiment produces an unexpected result, how do we know if it's evidence of a multiverse or simply a new phenomenon within our own universe? These are questions that keep researchers up at night, pushing them to refine their methods and develop new technologies. Another hurdle is the speculative nature of the theories themselves. While ideas like string theory and the multiverse are mathematically elegant, they're incredibly difficult to test directly. This has led some critics to argue that these theories are more philosophy than science. But for those working in the field, the pursuit is worth it. Every experiment, every observation brings us one step closer to understanding whether our universe is truly alone, or just one thread in a vast cosmic tapestry. As we continue to push the boundaries of science, one thing is clear. The search for evidence of multiverses and universe collisions is as much a journey of imagination as it is of discovery. It challenges us to think beyond the limits of our own reality and to consider possibilities that might seem impossible today. And while we may not have all the answers yet, the questions themselves are a testament to the power of human curiosity. Could we be on the verge of a breakthrough that reshapes our understanding of existence? The search is far from over, and that's what makes it so exciting. Exploring the multiverse is one of the most thrilling frontiers of modern science, but it's also one of the most challenging. While the idea of multiple universes colliding or existing alongside ours sparks endless fascination, the reality is that studying these phenomena is far from straightforward. So, what's holding us back? The answer lies in a mix of technological limitations, gaps in our understanding, and even philosophical questions that push the boundaries of what science can address. At the heart of the challenge is the sheer scale of what we're trying to observe. Multiverses, if they exist, operate in dimensions or realms that are entirely beyond our perception. Our universe is vast enough, with its billions of galaxies and trillions of stars, but trying to detect another universe, or even the subtle signs of one intersecting with ours, requires instruments and methods that are light years beyond what we currently have. For example, while particle accelerators like the Large Hadron Collider can recreate extreme conditions, they're still limited in their ability to probe the higher dimensions where other universes might exist. It's like trying to detect a whisper in a hurricane. The signals we're looking for are incredibly faint, and the tools we have aren't yet sensitive enough to pick them up. Another major hurdle is the speculative nature of multiverse theories. Unlike many scientific ideas that can be tested and observed directly, multiverses often exist in the realm of mathematical models and theoretical frameworks. String theory, for instance, suggests that our universe is one of many branes floating in higher dimensional space, but proving this idea requires evidence that's incredibly difficult to gather. Even if we detect anomalies in particle collisions or gravitational waves, how do we know they're evidence of another universe and not just an unknown phenomenon within our own? This uncertainty makes it hard to move these theories from the realm of speculation into the world of testable science. Philosophical questions also play a role in slowing progress. The very idea of a multiverse challenges our understanding of reality, raising questions about what it means for something to exist if we can't observe or interact with it directly. Some scientists argue that theories about multiverses are more metaphysics than physics, pushing the boundaries of what science can realistically explore. This debate isn't just academic, it affects how resources are allocated and which research paths are prioritized. Without a clear way to test these ideas, some in the scientific community remain skeptical, which can slow the momentum of multiverse research. Then there's the practical side of things. Funding for cutting-edge scientific projects is always a challenge, and multiverse research is no exception. Building the next generation of particle accelerators or gravitational wave detectors requires billions of dollars and decades of effort. Convincing governments, institutions, and the public to invest in these projects isn't easy, especially when the outcomes are so uncertain. It's a classic catch-22. We need better technology to explore multiverses, but developing that technology requires resources that are hard to justify without clearer evidence. Despite these challenges, the field isn't standing still. Scientists are constantly refining their theories and developing new ways to test them. Advances in quantum computing, for example, could one day allow us to simulate higher dimensional spaces, giving us a glimpse into what other universes might look like. And as gravitational wave detectors become more sensitive, they might pick up signals that hint at collisions between universes or other cosmic anomalies. The future of multiverse research is far from bleak. It's just waiting for the right breakthroughs to push it forward. So, what does the future hold for this field? It's hard to say for certain, but one thing is clear. The pursuit of understanding multiverses is as much about innovation as it is about imagination. Every new theory, every experiment, and every technological leap brings us closer to answering some of the biggest questions in science. And while the road ahead is filled with challenges, it's also brimming with potential. After all, the universe or multiverse has a way of surprising us when we least expect it. What does the future hold for multiverse research? As we stand on the edge of this cosmic frontier, the possibilities are as vast as the multiverse itself. Imagine a world where the tools we use to explore the cosmos are no longer limited by the constraints of our current technology. Advances in quantum computing, artificial intelligence, and space-based observatories could revolutionize our ability to detect and understand phenomena like universe collisions. These technologies might allow us to simulate higher dimensional spaces, decode the subtle signals of gravitational waves, or even peer into the hidden layers of reality. The next decade could bring breakthroughs that reshape our understanding of existence itself. One of the most exciting prospects is the development of next-generation particle accelerators. While the Large Hadron Collider has already given us incredible insights, future machines could be exponentially more powerful, capable of probing energies that bring us closer to recreating the conditions of universe collisions. Imagine a particle accelerator that stretches across continents or even orbits Earth, harnessing the vacuum of space to eliminate interference and achieve unprecedented precision. Such a machine could reveal particles or forces that hint at the existence of other universes, providing the evidence we need to take multiverse theories from the realm of speculation into the world of scientific fact. But it's not just about bigger and better machines. The future of multiverse research also lies in collaboration across disciplines, borders, and even species. As we develop more sophisticated telescopes and detectors, the data we collect will require new ways of thinking and analyzing. Artificial intelligence could play a crucial role here, sifting through vast amounts of information to identify patterns or anomalies that human scientists might miss. And as we venture further into space, we might even encounter civilizations that have already explored these questions, offering their own insights and technologies to aid our understanding. The idea of a global or even galactic scientific community working together to unlock the secrets of the multiverse is both inspiring and humbling. Of course, the path forward won't be without challenges. The sheer complexity of multiverse theories means that progress will likely be slow and incremental, requiring patience and persistence. Funding for ambitious projects will remain a hurdle, as will the skepticism of those who view these ideas as too speculative. But history has shown us that the most profound discoveries often come from exploring the unknown, even when the odds seem insurmountable. The search for multiverses isn't just about satisfying our curiosity, it's about expanding the boundaries of human knowledge and redefining our place in the cosmos. Beyond the scientific implications, this research has the potential to transform how we see ourselves and our universe. If we discover that our reality is just one of many, it could shift our perspective on everything from philosophy to art to ethics. What does it mean to exist in a multiverse where countless versions of ourselves might be living different lives? How do we navigate questions of identity, free will, and purpose in a cosmos that's infinitely more complex than we ever imagined? These are questions that go beyond science, touching the very core of what it means to be human. As we look to the future, one thing is certain. The exploration of multiverses is a journey that will challenge us, inspire us, and ultimately change us. Whether it's through groundbreaking discoveries, technological innovations, or philosophical revelations, the pursuit of understanding these cosmic mysteries is a testament to the boundless curiosity of the human spirit. And as we continue to push the limits of what we know, we're reminded that the universe, or multiverse, is a place of endless wonder waiting for us to uncover its secrets. The next chapter in this story is just beginning, and the possibilities are as infinite as the realities we seek to understand. What if the collision of universes wasn't just a cosmic event? What if it was a catalyst for transformation on every level? The implications of understanding these collisions stretch far beyond the realm of astrophysics, reaching into the very fabric of how we see ourselves, our world, and our place in the cosmos. Imagine a future where the knowledge gained from studying universe collisions reshapes science, philosophy, and even the way we live our daily lives. This isn't just about unlocking the secrets of the multiverse. It's about redefining what it means to exist in a reality that's infinitely more complex than we've ever imagined. Let's start with science. If universe collisions are real, they could revolutionize our understanding of physics. For decades, scientists have been searching for a theory of everything, a single framework that explains all the fundamental forces and particles in the universe. The collision of universes might hold the key to this grand unification. By studying the aftermath of such events, we could uncover new laws of physics, ones that bridge the gap between quantum mechanics and general relativity. This wouldn't just be a breakthrough, it could be the foundation for a new era of discovery, where the boundaries of our knowledge are pushed further than ever before. But the impact doesn't stop at science. The philosophical implications are equally profound. If we discover that our universe is just one of many, it forces us to confront some deeply existential questions. What does it mean to exist in a multiverse where countless versions of ourselves might be living different lives? How do we define identity, purpose, or even reality itself when the very fabric of existence is called into question? These aren't just abstract ideas, they're questions that could reshape how we think about everything from ethics to art, challenging us to see the world in ways we never have before. Now, let's bring this closer to home. What could this mean for everyday life? The technologies born from understanding universe collisions could transform our world in ways we can barely imagine. For instance, if we learn to harness the energy released during such events, it could provide an almost limitless source of power, solving global energy crises and fueling advancements in everything from transportation to medicine. Or consider the possibility of new materials or technologies inspired by the physics of higher dimensions. Imagine devices that manipulate time or space, or communication systems that transcend the limits of our own reality. The practical applications are as exciting as they are endless, and then there's the big question: what does this mean for humanity's place in the cosmos? If we're part of a multiverse, it changes everything. No longer are we confined to a single, isolated reality. We're part of something far grander, a tapestry of universes, each with its own story to tell. This realization could inspire a new sense of unity and curiosity, encouraging us to think beyond the limits of our own world and consider the infinite possibilities that lie beyond. It's a perspective that's both humbling and empowering, reminding us that the universe, or multiverse, is a place of endless wonder waiting to be explored. As we reflect on these possibilities, one thing becomes clear: the study of universe collisions isn't just about understanding the cosmos, it's about understanding ourselves. It challenges us to think bigger, to dream bolder, and to see the world not as it is, but as it could be. Whether it's through groundbreaking science, transformative technologies, or profound philosophical insights, the exploration of intersecting universes invites us to imagine a future where the boundaries of reality are no longer limits, but gateways to infinite potential. So, what does this mean for humanity? The answer might just change everything we thought we knew about our place in the grand tapestry of existence. What if the discovery of intersecting universes didn't just change our understanding of the cosmos, it changed how we see ourselves? For centuries, humanity has gazed at the stars, wondering if we're alone in the universe. But what if the question isn't just about life on other planets, but life in other realities? The idea of intersecting universes forces us to confront a profound truth. Our place in the cosmos might be far smaller or far larger than we ever imagined. Are we a solitary species adrift in a vast, empty universe, or are we part of an infinite tapestry of realities, each one teeming with its own forms of life and intelligence? The answer could redefine not just our science but our sense of purpose and belonging. On one hand, the concept of a multiverse might humble us. If our universe is just one of countless others, each with its own laws of physics and unique forms of existence, it's a reminder of how small we truly are in the grand scheme of things. The challenges we face, climate change, inequality, conflict, might seem insignificant when viewed against the backdrop of an infinite multiverse. But this perspective isn't meant to diminish our struggles, it's an invitation to think bigger. If we're part of something so vast and interconnected, perhaps our actions matter more than we realize. Every decision, every discovery, every act of kindness could ripple across realities, shaping not just our world but the fabric of existence itself. On the other hand, the idea of intersecting universes could ignite a new era of exploration and ambition. If other realities exist, teeming with life and knowledge, it's a call to push the boundaries of what we think is possible. Imagine the breakthroughs we could achieve if we could learn from civilizations that have evolved under entirely different laws of physics. Their technologies, philosophies, and art could inspire us to rethink our own limitations and strive for greatness. The multiverse isn't just a scientific concept, it's a source of endless wonder, a reminder that the universe or universes are full of mysteries waiting to be uncovered. But with this knowledge comes responsibility. If we're not alone and if our actions can influence other realities, what ethical obligations do we have? The idea of intersecting universes raises questions about how we should interact with other forms of life, should we ever encounter them. Would we approach them with curiosity and respect, or would fear and misunderstanding lead to conflict? History has shown us that first contact between civilizations rarely goes smoothly, even when both sides share the same reality. With beings from another universe, the stakes would be even higher. Their very existence could challenge our assumptions about life, intelligence, and the nature of reality itself. How we respond to these challenges could shape not just our future, but the future of all realities. As we ponder these questions, one thing becomes clear. The idea of intersecting universes isn't just about the cosmos, it's about us. It challenges us to think beyond the limits of our own reality and consider the infinite possibilities that lie beyond. Whether it humbles us or inspires us, the multiverse invites us to see ourselves not as isolated beings, but as part of something far greater. And in doing so, it doesn't just change how we see the universe, it changes how we see ourselves. So are we alone? The answer might not just redefine our place in the cosmos, it might redefine what it means to be human. What if the knowledge of universe collisions came with a responsibility we've never considered before? As we delve deeper into the mysteries of intersecting realities, we're faced with a profound question. How should we, as a species, use this understanding? The ability to manipulate or even predict such cosmic events carries immense power, but with great power comes great ethical dilemmas. Should we attempt to control these phenomena, or would doing so risk unraveling the very fabric of existence? The answers aren't just scientific, they're deeply moral, forcing us to confront our role in a cosmos that's far more interconnected than we've ever imagined. Let's start with the potential rewards. If we could harness the energy released during a universe collision, it could revolutionize our civilization. Imagine a world powered by the remnants of cosmic events, where energy scarcity is a thing of the past. The technologies born from this knowledge could propel us into a new era of exploration, allowing us to travel further and faster than ever before. But here's the catch: with such power comes the risk of misuse. What happens if this knowledge falls into the wrong hands? Could the manipulation of universe collisions be weaponized, leading to catastrophic consequences not just for our reality, but for others as well? The stakes are unimaginably high, and the ethical implications are just as vast. Beyond the practical risks, there's a deeper philosophical question. Do we have the right to interfere with the natural order of the multiverse? Universe collisions are events on a cosmic scale, governed by laws that we're only beginning to understand. Attempting to control or manipulate them could disrupt delicate balances that have existed for billions of years. It's a bit like trying to redirect a hurricane, even if we could, should we? The potential for unintended consequences is enormous, and the ripple effects could extend far beyond our own reality. This isn't just about what we can do, it's about what we should do. And then there's the question of responsibility to other realities. If intersecting universes bring us into contact with other forms of life, how do we ensure that our actions don't harm them? The ethics of inter-universe interaction would require a level of humility and cooperation that humanity has rarely demonstrated. We'd need to approach these encounters with respect, recognizing that our understanding of existence is limited and that other civilizations might have their own perspectives, values, and priorities. The idea of a cosmic code of ethics governing how we interact with other realities might sound like science fiction, but it could become a necessity if we're to navigate the multiverse responsibly. So, what can we learn from these bold theories? Beyond the scientific breakthroughs and technological advancements, the study of universe collisions teaches us something fundamental about ourselves. It challenges us to think beyond the confines of our own reality and consider the broader implications of our actions. It reminds us that we're part of something far greater, a cosmos that's infinitely complex and interconnected. And it forces us to confront the ethical responsibilities that come with knowledge, pushing us to ask not just what we can do, but what we ought to do. As we explore these questions, we're reminded that the pursuit of understanding isn't just about discovery, it's about wisdom. The knowledge of universe collisions doesn't just expand our understanding of the cosmos, it deepens our understanding of ourselves. And in grappling with these ethical dilemmas, we're not just shaping the future of science, we're shaping the future of humanity. Could the key to navigating the multiverse lie not in our intellect, but in our integrity? The answer might just define our place in the grand tapestry of existence. What if the greatest lesson from exploring bold theories like universe collisions isn't about the cosmos at all, but about us? At its core, the journey to understand these mind-bending ideas is a testament to the power of human curiosity and imagination. It's not just about unraveling the mysteries of the multiverse, it's about celebrating the relentless drive to ask questions, challenge assumptions, and dream beyond the limits of what we know. And in that process, we're reminded that the pursuit of knowledge is as much about the journey as it is about the destination. Curiosity is the spark that ignites discovery. It's what compels us to look up at the stars and wonder what lies beyond, or to peer into the tiniest particles and ask how they shape the fabric of reality. When we explore bold theories like universe collisions, we're not just chasing answers, we're embracing the unknown, daring to imagine possibilities that might seem impossible today. This kind of curiosity doesn't just advance science, it fuels our sense of wonder, reminding us that the universe is a place of endless mystery and potential. Creativity plays an equally vital role. The theories we've explored, parallel universes, intersecting realities, and cosmic collisions, are born from the marriage of rigorous science and boundless imagination. They challenge us to think in new ways, to see the familiar through fresh eyes, and to connect dots that might seem unrelated at first glance. It's this creative thinking that allows us to push the boundaries of what's possible, turning wild ideas into testable hypotheses and transforming abstract concepts into tools for understanding the cosmos. But curiosity and creativity alone aren't enough. Open-mindedness is the glue that holds it all together. To explore bold theories, we must be willing to question what we think we know, to entertain ideas that might seem absurd or even unsettling, and to remain humble in the face of the vast unknown. This openness isn't just a scientific virtue, it's a deeply human one. It reminds us that knowledge is never static. It's a living, evolving process shaped by the questions we ask and the perspectives we bring to the table. So, what can we take away from this journey into the unknown? First, that the universe or multiverse is far stranger and more complex than we've ever imagined. Second, that our understanding of reality is constantly evolving, shaped by bold ideas and the tools we use to explore them. And finally, that the pursuit of knowledge is a celebration of what makes us human, our curiosity, our creativity, and our capacity to dream. As we close this exploration, let's remember that the boldest theories aren't just about finding answers, they're about asking better questions. They challenge us to think bigger, to imagine more, and to see the world not as it is, but as it could be. Whether we're scientists, dreamers, or simply curious minds, the journey to understand the cosmos is a reminder that the universe is full of mysteries waiting to be uncovered. And in that journey, we're not just discovering the cosmos, we're discovering ourselves. As we near the end of this cosmic exploration, let's take a moment to reflect on the extraordinary journey we've taken together. From the mind-bending physics of universe collisions to the profound philosophical and ethical questions they raise, we've ventured into a realm where science and imagination collide. We've explored how two universes might intersect, what such an event would look like, and how it could reshape not just the cosmos, but our understanding of reality itself. We've delved into the role of dark matter, black holes, and higher dimensions, and even pondered what it might mean to encounter life from another universe. Each step has challenged us to think bigger, to push the boundaries of what we believe is possible, and to embrace the unknown with curiosity and wonder. But this isn't just a journey about the cosmos, it's a journey about us. The study of universe collisions reminds us that the pursuit of knowledge is as much about asking bold questions as it is about finding answers. It's about daring to imagine scenarios that stretch the limits of our understanding, and then using science to explore whether those scenarios could be real. This process, this dance between curiosity and discovery, is what drives humanity forward. It's what compels us to look at the stars and wonder, to peer into the depths of space and time, and to seek out the secrets of existence. And yet, the implications of these theories go far beyond science. They challenge us to think about our place in the multiverse, to consider what it means to exist in a reality that might be just one of many. They force us to confront ethical dilemmas, like how we might interact with other universes or the responsibilities that come with such immense knowledge. These aren't just abstract ideas, they're questions that touch the very core of what it means to be human. They remind us that the universe or universes are not just places to explore, but mirrors that reflect our own potential, our limitations, and our boundless capacity for imagination. So, what if the collision of universes isn't just a theory, but a reality waiting to be discovered? What if, somewhere out there, two realities are already intersecting, reshaping the fabric of existence in ways we can't yet comprehend? The thought is both thrilling and humbling, a reminder that the cosmos is full of mysteries we've only begun to uncover. And while we may not have all the answers yet, the questions themselves are a testament to the power of human curiosity and the endless possibilities that lie ahead. Thank you for joining me on this journey into the unknown. Whether you're a seasoned space enthusiast or someone just beginning to explore the wonders of the multiverse, I hope this exploration has sparked your imagination and left you with a sense of awe for the infinite possibilities that surround us. If these ideas have inspired you, or if you have your own thoughts about universe collisions and the multiverse, I'd love to hear from you. Share your perspectives in the comments below, and let's keep the conversation going. After all, the pursuit of knowledge is a shared adventure, one that's as vast and interconnected as the cosmos itself. Until next time, keep dreaming, keep exploring, and never stop asking the big questions. The universe or multiverse is waiting.